Okay, I'm going to go ahead and work through a problem, assuming that the population standard deviation is unknown. In an earlier video, I talked about utilization of the t-distribution, and again, we use it whenever the population standard deviation is unknown. So we're going to develop another confidence interval, but again, this time we're going to use the t-distribution. So we're going to look at page 294, number 11. We've got the owner of Britain's egg farm wants to estimate the mean number of eggs produced per chicken. We've got a sample of 20 chickens showing that they produce an average of 20 eggs a month, and the standard deviation is 2 eggs per month. Okay, for part A, they ask, what is the value of the population mean? Well, that value is unknown. Okay, the only way we would know for sure is we would have to include all chickens in our study. We may not have the time, the money, whatever the case may be to do that, so we've taken a sample. And so the population mean is unknown. Our best estimate would be the mean of 20 eggs per month. This best estimate is referred to as our point estimate. So again, when you hear that term point estimate, you are referring to our best estimate of the unknown population parameter. Why do we need to use t, and what assumption do we need to make? We use t because the population standard deviation is unknown, and because we have a sample size that is less than 30, in this case it's 20, we're going to have to assume normality, okay? Again, because of the central limit theorem, we would have to have samples of 30 or higher to be able to assume that the distribution of the means is normal, even if the actual distribution found in the population is not normal. So again, we're going to assume normality for a 95% confidence interval, the value of t. Okay, we're going to go back. Like we did previously, confidence interval has 2 tails, 95% confidence interval. So we're going to go over 5. The sample size was 20. 20 minus 1 equals 19 degrees of freedom. And we go down and you'll see the 2.093. So that's going to be the critical value for t in our equation. They ask you for the margin of error. Okay, the margin of error is the plus and minus from the sample mean. So I'm going ahead and work this one out. So the margin of error is going to be equal to our t value, the 2.093 times the standard error. We get the standard error by taking the standard deviation of 2, dividing it by the square root of the sample size, which was 20. So here we get 20.093 times 0.447217, that comes up to 0.936. So our confidence intervals here in E, we've got 20 plus or minus 9.36. If we show this graphically, on the lower end, again, this would be our t-distribution. Our point estimate is 20, lower end of the 95% confidence interval, 19.064. On the upper end, 20.936. Had this been a 99% confidence interval, this value would be lower, this value would be higher. Had this been a 90% confidence interval, this value would be higher, this value lower. Again, that's the trade-offs between precision and then level of confidence. For part F, they ask, would it be reasonable to conclude that the mean is 21 eggs? And there we would have to say no, because 21 falls outside the range of our confidence interval. Now, do recall that it is possible for the value of the unknown population parameter to actually fall outside the range of the confidence interval. Okay, it is possible. In this case, we've got a 95% level of confidence. So I feel, relatively good that the true value is somewhere between 19.064 and 0.936. And then they ask us 25. 25 will be way, way, way over here. So that is incredibly unlikely that would be the case. So so neither of those is reasonable. Now let's go ahead and share the screen and show you how to do this in Megastat Excel. So let's share the screen. Let's go to Excel. Okay. So we've got our data here. We're going to go to add-ins. Over to Megastat. Once again, we're doing confidence intervals. Now, the key thing here is, here we can either toggle Z or T. And the previous one, we had it on Z. Here, we're going to go to T because we're using the T distribution. I've already got the values in here. The this again, confidence interval for a mean. Let's go back to T here. Our sample mean was 20. The sample size was also 20. The standard deviation was 2. And so we've got it on T, 95% confidence interval. Now you can go 99, 95, 90. We're going to stick with 95. Hit OK. And boom, there we get the t-value of 2.093, the 19 degrees of freedom, the upper and lower ends of our confidence intervals. Note that again, that both 21 and 25 fall outside of that range. It's very, very easy to do these type calculations, both by hand and using the Excel Megastat. So hopefully this helps, and look forward to the next recording.